Good morning, students. Yesterday, we have seen the uses of an influence line diagram. So, in that one, first we have seen to determine the value of the quantity for a given system of the loads on the span of the structure. So, today we'll see the second use of that one. So, what is the second use? To determine the position of a live load for a quantity for the quantity for the quantity in bracket for which the influence line is drawn to determine the position of a live load for the quantity to have the maximum to have the maximum value and hence to calculate the maximum value of the quantity. Maximum value of the quantity. What is the meaning? That means, suppose we have a span, okay, so when the load is moving on that span, at what position we will get the maximum support reaction, because now we are seeing for the support reactions, correct? Okay, so to determine the position of live load, that means if the live load is moving from one point to the another point over a span, at what location, if this load will be there, for that we'll get the maximum reaction. We'll see. Okay, so we'll take now we'll see one numerical. Suppose a UDL of magnitude 80 kilonewton per meter of span 4 meter. This is what the UDL, okay, and which is moving. Suppose this is a girder, simply supported girder, okay, of 16 meter, of 16 meter, correct? Now, so this is A and B. Now, if this UDL is moving over the span, okay, for 16 meter span, at what location this load should be there, so that we'll get the maximum reaction, support reaction VA, VB. We have to find out. So it is simple, okay. So we know the influence line diagram for reaction VA and VB. So first we'll see for the reaction VB, maximum okay, maximum value for reaction VB. correct? Now, so once again I will draw this girder of 16-meter span, and I also draw I will also draw the influence line diagram for a reaction VB. So this is what the influence line diagram. So this is what the maximum 1, this is 0, correct? This is what the influence line diagram for ILD for reaction, we can call it as a support reaction VB, correct? Now, so we know the support reaction, this is diagram. Now if the UDL is here, so we know how to calculate the VB reaction. We have to multiply. So yesterday we have seen, if you want to calculate the VB for UDL, okay, for reaction VB must be equals to the intensity of the load into area of the load influence line diagram between C and D. That means covered by this span, area of this covered by the span. That means suppose the UDL is here, okay, for 4 meter, then what we have to do, intensity of this load multiply by this area of the triangle, area of this hatch portion, correct? Now, so we know we can judge from this triangle, so where we'll get the maximum area. So here we have maximum area because here is 0, here 1. So if the UDL is at this position, that is 4 meter, now this span becomes 12 meters, correct? So now this is what the hatch portion, so we'll get the maximum reaction VB, because what, the reaction VB, value of reaction VB must be equal to the intensity of load multiply by area of the influence line diagram under this load, correct? Under this load. So what will be 80 kilonewton meter? It is a intensity of this UDL, okay? And what is this one? This position is 12 by 16, correct? So we have seen 16, so 12 by 16, correct, plus I will write 16 by 16 here for the calculation, h by 2, that is a 16 divided by 2, sorry, no, so what is the height? Height is 4 meter, 4 divided by 2, so what is 80 into so the answer for this maximum reaction, okay, equals to 280 kilonewton, so VB, okay, you got. So this, what is the use of this influence line diagram? From this influence line diagram we will get to know that if the load is at this position, we'll get the maximum reaction VB, because of this influence line diagram, because where the area is more, under that, if that load will be there, we'll get the maximum reaction VB. Now we'll take the second example. Now we'll have the second example. Suppose we have uniformly moving, we have the roller, okay, moving loads. Suppose, so we have 80 kilonewton load, then we have 200 kilonewton load. Then we have again 200 kilonewton load, and the last we have 60 kilonewton load. So these are the loads, and four meter and 4 meter.